Session 3.2 Measure of Variation. In the session 3.1, we learn about the central tendency. We know how to find the mean, median, and the mode. For these sessions, we will learn how to find the range, standard deviation, and variance. How to measure the spread out data. Look at this example. We do have a free data set of the quiz score. We do have the session A. Looks like all the students getting the same points. Session B, some students getting 0, but some students getting the perfect. Okay, we assume 10 points will be the perfect. And then session C, some students get like 4, some students get the 5, and some students get the 6. So if we have this free set of the data, let's try to find out the mean and the median. Let's use the calculator. Okay, remember how to do it? Click on the stat. Click on number 1 added. On the L1, we're gonna plug in the session A. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a 10 data. All of them is gonna be 5. Okay, 10 data. And then session B, that will be on your L2. And then session C, okay, all of them, they do have a 10 data. And then we're gonna click on the stat, click on the cal, number 1, one variable statistic. Okay, now let's find out the mean and the median for the session 1 first. Okay, now my session A will be on L1. Okay, enter. The frequency list, there's nothing here. Enter and then calculate. So you can see we do have the mean is equal to 5. Scroll down, median is also equal to 5. So let me write it down here. For the session A, mean is equal to 5, median is also equal to 5. And then let's look at the session B. Click on the stat again, go to the cal, number 1, one variable statistic. And my session B will be on L2. So second 2 for L2. Go to calculate. Okay, we still get the mean equal to 5. Median is also equal to 5. Now, last one, session C. Go to the cal, one variable statistic, second 3 for L3. Go to calculate. Okay, we still get the same thing. We do have the mean equal to 5, median also equal to 5. So we have this free set of the data. If we try to calculate the central tendency, it looks like exactly the same thing with the mean and the median. However, when you guys look at the data set of the quiz score, that will be a little bit different, right? Like session A, they will have all 5 here. Everyone getting 5 points. And then for the session B, half of the class getting no points, half the class getting the perfect score. And then the session C, there was no consistency as in session A, but not as widely varied as the session B. Right? So this is why we need to discuss the spread of a data set. Even though the mean and the median were 5, something is happening with the spread of the data. First one, let's talk about the range. The range is the difference between the maximum value and the minimum value of the data set. So this is gonna be your formula. Find out the range, find out the maximum data minus the minimum data. Okay, let's try on the first example. Let's visit example of peanut butter jar price. Find the range of the data set. So we do have the data in here. I want you guys try to use this formula, find out the range. After that, I want you guys interpret the answer in the context of the problem. So, formula. The range will be equal to the maximum value. This is gonna be the most expensive price for the peanut butter. And then the least expensive was gonna be $3.29. Use your calculator. You're gonna get 70 cents. Okay, so the range is equal to 70 cents in here. So interpret. This means that the difference between the most expensive and the least expensive jar in the sample is 70 cents. It gives us an idea of how much price vary among the jars in this sample. So you can think about it. If I find out the range is gonna be greater, let's say like $2, means like the data is more spread out. However, if we find out the range is really, really small, that means the price is gonna be about in the center, right? Or you could say like really, really close to the mean. Second one, standard deviation. The standard deviation, you could use the sigma or the S to represent it. It's a measure of variation based on how far each data value deviates or is different from the mean. Okay, talking about how far from each data from the mean. And standard deviation first is always positive. Okay, always positive. You can take a look for the formula. Okay, standard deviation. Both of them, you need to take the square root. So that's why standard deviation is always positive. And then second, standard deviation is 0 if all the data values are equal and will get larger as the data spread it out. Okay, so you could think about like the example here. Okay, the section A. All the data are exactly the same thing. If I try to use the calculator, okay, I'm gonna go back. Number 1 for the L1, section A is on L1. Let's look at the standard deviation. Standard deviation or sample standard deviation is also equal to 0 because all the data set are exactly the same thing. Okay, one more time, standard deviation is calculate how far from each data to the mean. Since the mean and the data are exactly equal to 5, that's why the standard deviation that will be equal to 0. So second one, standard deviation is 0 if all the data values are equal and will get larger as the data spread it out. So if the data is much more spread it out, you will get the larger standard deviation. Number 3, has the same units as the original data. So from the previous example, we are talking about the peanut butter jar price. So the unit is dollar. When you calculate the standard deviation, the unit is also equal to the dollars. And then can be highly influenced by outlier, similarly like the mean. So remember that from the previous sessions, we talked about what mean is very sensitive to the outliers. Same idea with the standard deviation, very sensitive to the outliers. Last one is interpret as the average is the mean, give or take the standard deviation. So this is a simple way to explain what standard deviation measure. The means tell you the typical or average value. And the standard deviation tells you how far on average the data values fall from the mean. Okay, so if we're working on the population standard deviation, we'll be using the sigma. Okay, this is the sigma, looks like that one. Don't mess up with the data. Okay, the sigma, it looks like the 6 and a little bit bent to the right. And then S, this is represent the sample standard deviation. Okay, I need you guys remember all the notation, the mean, the median, standard population standard deviation, or sample standard deviation. Now, let's look at the formula. Population standard deviation of a variable is the square root of the sum of square deviation about the population mean divided by the number of observations in the population. Okay, so you can see x1 represent the first data. The first data minus the population mean, take the square, and then plus the second data minus the population mean, take the square again, until the last one. Okay, and then the n, this is represent the observation in the population. Okay, capital letter N. And sample standard deviation, we use the S to represent it. Formula is pretty similar. Only difference is population standard deviation will be using N, the capital letter N, divided by the N only. But for the sample, that will be divided by the lowercase letter n minus 1. Okay, so you can see the answer will be different from the population standard deviation and the sample standard deviation. So this is the formula for the sample standard deviation. You can see we do have the summation notation here. Okay, the x here represent each of the data. Okay, data 1 minus the sample mean square plus data 2 minus the sample mean square. Okay, we're gonna remember this formula, sample standard deviation. And then the formula for the sample standard deviation, we just talked about this guy, right? We do have another different formula. Okay, I will show you guys the example using both of the formula. You only need to pick one. Okay, you only need to pick one formula for your homework and the exam. And make sure you guys show me all your work, how to plug into the formula and then get the answer. And then after the standard deviation, we're gonna talk about the variance. Okay, variance is the standard deviation square. So the formula will be you taking square of this guy, so square root will be goes away. And this is called variance. So the unit is also square unit. Example 2. Let's use this example for the first formula. First formula talking about this guy. Okay? So we use the example 1. Find the standard deviation and variance. Use the table to organize your calculations. Interpret the standard deviation in context of the scenario. So first, we do have 5 data, the peanut butter jar price. And I want you guys try to find out the mean. Okay, show me the word, how you find the mean. Remember, add it all up, divided by number of the datas. And then write it down the notation. The x bar represent the sample mean. Sample mean equal to, add it all up, divided by 5, because I have 5 datas here. Use your calculator. You're gonna get $3.68. Okay, that will be the mean. So let's write down the mean on the table. Now, we're gonna do it like step by step. We're gonna use the x minus the mean. Okay, that will be the x bar here. Okay, so data value, first one, $3.29 minus the mean, minus the $3.68. Use your calculator, you're gonna get this guy. And then we're gonna use this guy, take the square. Okay, I want you guys try finish this one. Okay, subtract it, price the data minus the mean, and then take square for this guy. Try to finish this table. After you're done, add it all up here. Okay, summation of this one, add it all up, find out the total. Okay, check your work. And then add it all up here. Okay, now look at the formula. We do have the square root of summation x minus the mean square, which is gonna be this guy. So I'm gonna plug in here. And then n will be 5, so divided by 5 minus 1. Use your calculator, you're gonna get this one. And then take the square root, you will find the sample standard deviation will be 26 cents. So this is not really large number, right? So we could believe the data is not really spread out. After that, you're gonna find the variance. Okay, you're gonna take square of this guy. So think about it. 0.26, take square, you're gonna go back for this one. So this is gonna be your sample variance. On the exam, if you want to use this formula, you don't have to submit the table. Okay, you could just strictly plug into this formula one by one and then calculate it. Okay, interpret the standard deviation. So the average peanut butter jar price is $3.68. This is talking about the mean. Okay, the mean. Average peanut butter jar price is $3.68. Give or take. Okay, talking about the standard deviation, which is gonna be 26 cents with a range of 70 cents. Okay, this is, we got it from the example 1. Okay, find out the range. Okay, same example, but this time we're gonna use the second formula. Again, you don't have to know both of them. You could only pick one formula. For me, I would think this one is much easier. Okay, and then I'm gonna show you guys why with the calculator. So you can see in my formula, we do have the summation of x. The x is talking about the data. Okay, we already have the data here. So add it all up, you're gonna get $18.41. Okay, summation of x. So this is represent this guy, summation of x. And then we do have the summation x squared. This is talking about you're gonna take square of each data and then add it all up. So first one, the x talking about this data, $3.29, you're gonna take square. Second one, do the same thing. Okay, so check your work. After that, add it all up. You will have 68.0589. Okay, now we're gonna plug into this formula. So n talking about the number of the data. We do have a 5 data here. Summation x squared, which is gonna be this guy, 68.0589. Summation x, that will be $18.41. and then take square. Okay, so you plug it in, you should get this. Use your calculator. You will get the same answer like the previous example. Sample standard deviation equal to 0.26 cents. Same idea, variance. Take square of this guy, you're gonna go back here. That will be the sample variance. And then same thing, you interpret the standard deviation. Now, let me show you guys how to do it with your calculator. Okay, actually the step is exactly how you guys finding the mean. Okay, click on the step, number 1 added. This time, I'm gonna put in my data on the L1. Okay, so this is my data. Okay, make sure don't make mistake when you input the data. Then you're gonna go to the stat, cal, number 1, one variable statistic. And then my data is on L1, go to calculate, enter. So first, I have the mean 3.682. And then you're gonna see the SX here. Don't write with the X, okay? This is the calculator notation. Our sample standard deviation is just the S only. Okay, so S equal to 0.26, right? 0.26. They don't have the variance because they will assume that you would just take square of the standard deviation, that will become your variance. And then N equal to 5. Okay, I like to use this formula because when I use my calculator, I can double check my work. You could see the summation X here. Summation X equal to 18.41. 18.41. And then summation X squared equal to 68.0589. Right? After I use my table, I could double check my work with your calculator. Formula will be provided in the exam. Okay, I will provide both of them. Again, you only need to pick one formula, either the first formula or the second formula. Calculating the standard deviation of frequency table. From the session 3.1, we learned how to find the mean and median from a frequency table, and these sessions we also want to know how to find the standard deviation of a frequency table. So we'll be using the same example from the session 3.1. So below the data of 16 randomly select weights in pounds of models from a model agency. Construct a histogram from the data. Find the sample standard deviation. So look at the data. This means we do have a 4 model. Their weight will be on 85 pounds. And then we do have 2 models. Their weight will be 98 pounds. First, I need you guys calculate how many models are there. You could add it all up, or they given already. Below are the data of 16 random select weights, right? So when you add it up, that will be equal to 60. And then we found out the mean already. You could review the example from the session 3.1. Now we'll be using the first formula to find out the sample standard deviation. So first, we're gonna use the data value minus the mean. Okay, x minus x bar here. The data will be 85 minus the mean. And then you're gonna take square of this guy and then multiply by the frequency. Okay, frequency times the data minus the mean square. Okay, one more time. Frequency times take square of this guy. Okay, right? I want you guys try use your calculator, fill in this table first. And then at the end, try to add it all up here to see what you're gonna get for the total. Okay, check your word. Data minus the mean, and then take square. Okay, check all your work. And then you're gonna add it all up. You should find 4,282. Now, this one will be equal to the formula on your numerator. So plug it in. And then n, talking about the sample size. So we do have a 16 of it. So plug in n equal to 16. Use your calculator. You should get 16.90 pounds. Okay, so this is gonna be the sample standard deviation. Okay, now we do have the same example, and then we'll be using the second formula. So first, we're gonna find out the summation of x. Okay, summation of x, we're gonna use the data times the frequency. Okay, so 85 times 4. And then this one, we need to use the frequency times the data value and take square. Okay, so data take square and then times the frequency. Okay, I want you guys try. After you're done, add it all up to find out what is the summation x, what is the summation x squared. Okay, check your work. And then add it all up here. That will be your summation x. And then add it all up here. That will be summation x squared. And it's going to be 16 again. Okay. Use your calculator. You're going to get the same answer. Sample standard deviation will be equal to 16.90 pounds. Okay. So this is the instruction how to use your TI-84 calculator to finding the standard deviation of a frequency table. Let's try to do it together. Go to the stat, go to number 1 added. Okay, we just need the data here. We're gonna input the data on the L1, frequency that will be on your L2. Okay, double check your data. Now go to the stat, go to the cal, choose one variable statistic. My data is gonna be on L1, frequency that will be on your L2. So second 2 for L2. Go calculate. So double check, we do have the mean. You could go back. You could check your mean will be 106.063. Good. And then we have the sample standard deviation, 16.89. Okay, so 16.90. Also, you could check your summation x. Okay, summation x is going to be 1,697. Summation x squared, 184,271. Calculating and interpreting the z-score. A z-score of particular data point is the number of standard deviation away from the mean given by the formula. So look at the formula. These two formulas are exactly the same thing. It's just one for the parameter, one for the sample. So this one, the x will be the data minus population mean and divided by population standard deviation. This one will be the data x minus the sample mean divided by sample standard deviation. And the z-score are uniqueness and are efficient value to compare the statistic from different distribution. Okay, let's try on this example. The mean score on a test for a statistic class was an 82 with a standard deviation of 7 points. If grade A is 93 points, what is the z-score for an A on the test? Interpret the results. So we try to find the z-score, write down the formula. So x, that will be your data. And then mean will be 82, standard deviation will be 7. So plug it in, use your calculator. You're gonna find out the z-score is gonna be 1.57. Okay, interpret the result. We could say that a score of a 93 points is 1.57 standard deviation above the mean test score. So that means this is a higher than the average. Okay, if we find it as a negative numbers, that means it would be lower than average. Okay, try on this example. A student Pat was done taking midterms. She received a grade of 82 on her statistic exams, where the mean grade was 74 and the standard deviation was 12. And she received a grade of 72 on her biology exam, where the mean grade was 65 and the standard deviation was 10. Lastly, she received a grade of 91 on her kayaking exam, where the mean grade was 88 and the standard deviation was 6. In what class did Pat relatively scored better? So you can see she want to compare like the three subjects, the statistic, biology, and the kayaking exam. However, each test they will have a different mean and the standard deviation. So how can we compare which one is relatively scored better? So for this example, we'll be using the z-score. So for statistic class, I'm going to put the S here. This is for z-score on your statistic. Okay, let's try to plug in the information. So we receive a grade of 82, right? So that will be the data. And then the mean will be 74, standard deviation will be 12. Plug it in. You're gonna see the z-score will be 0.67, so that will be above the average. And then now we're gonna work on the biology exam. Do the same thing. Try. And also I want you guys plug in the kayaking exam also. Okay. Check your work. Biology exam, so receive the 72, right? And then the mean will be 65, standard deviation will be the 10. So she got 0.70. Again, it's gonna be above than the average, right? Last one, check your work. You should get 0.50. So now you find all the Z-score for each subject. You can compare for it. Which one is relatively scored better? The highest one should be biology. Okay, so answer the question. So Z-score is telling you like how many standard deviation above or below the mean. When you try to compare different sets of the data, you could convert it to the Z-score and then you could compare for it. Empirical rule. Empirical rule describes how data behave in a normal distribution or the bell-shaped distribution. And it tells us what percentage of the data fall within 1, 2, and 3 standard deviation of the mean. So look at here. This is the bell shape. In the middle part here, that will be your mean. Okay, when you use the mean plus 1 standard deviation, that will be somewhere like here. And also the mean minus 1 standard deviation. So by the empirical rule, we're gonna say that about 68% of the data is within 1 standard deviation. So this is talking about this part. 68% of the data will be falling within 1 standard deviation. And then about 95% of the data is within 2 standard deviation. Okay, 2 standard deviation, talking about the mean plus 2 standard deviation and the mean minus 2 standard deviation. So like here, including the 68%, like here, about 95% of the data falls within the 2 standard deviation. And then at last, about 99.7% of the data is within 3 standard deviation. So 3 standard deviation here, 3 standard deviation here. Okay, so I need you guys to remember a couple things. First, empirical rule is only work for the normal distribution. Second, I need you guys to remember 68% within 1 standard deviation, about 95% within 2 standard deviation, and about 99.7% is within 3 standard deviation. Unusual observation. The empirical rule helps us identify when a data value is a typical or unusual in a distribution that is approximately normal. Remember empirical rule, we're just saying that 68% is within 1 standard deviation. About 95% of the data is within 2 standard deviation. And 99.7% of the data fall within 3 standard deviation here. And then a value is considered unusual if it is more than 2 standard deviation away from the mean. Okay, so you could see the maximum usual will be the mean plus 2 standard deviation. So it's somewhere like here, mean plus 2 standard deviation. And then the minimum usual will be the mean minus 2 standard deviation. Okay, so somewhere like here. So if a value is less than the mean minus 2 standard deviation, then we're gonna consider the data will be unusually low. Or if a data is above the mean plus 2 standard deviation, then we're gonna consider the data is unusually high. You also can use the Z-score to find out if the data is gonna be usual or unusual. When Z-score equal to 1, talking about there is a 1 standard deviation above the mean. When Z-score equal to 2, that means 2 standard deviation above the mean. Or if the Z-score equal to -1, means there will be 1 standard deviation below the mean. Okay, so when your Z-score is within -2 to 2, so it means inside this part here, then the data will be usual. However, if your Z-score strictly less than -2, so somewhere like here, then your data will be unusually low. Or if your z-score is going to be greater than 2, like here, then the data will be unusually high. Okay, let's try to do this example. Use the empirical rule to draw the conclusion about how many gifts do the children got for the Christmas, and assume the data have a normal distribution. Okay, one more time, empirical rule only work for the normal distribution. And then given the mean is equal to 10, standard deviation is going to be equal to 3. So first, we're going to find it out 1 standard deviation, 2 standard deviation, and 3 standard deviation. So I'm going to use the mean plus minus the sample standard deviation. Okay, the mean, which is 10, minus 1 standard deviation, you're going to get a 7 and 13. So I could say about 68% of those kids receive 7 to 13 gifts. And then now we're going to calculate plus minus 2 standard deviation. So the mean minus 2 times the standard deviation, which is going to be equal to 4, and also the 16. So I could draw the conclusion. About 95% of those kids receive 4 to 16 gifts. Last one, that will be plus minus 3 standard deviation. And then draw the conclusion, say about 99.7% of those kids receive 1 to 19 gifts. Okay, the picture is gonna be looks like that. In the middle part here, that will be equal to your mean. Okay, mean equal to 10. And then when you're adding 1 standard deviation, that will be 13 here. And minus 1 standard deviation, that will be 7. Okay, I need you guys try to draw the conclusion with complete sentence. Okay. Okay, next example. The graph isolates a normal distribution for the price paid for a particular model of HD television. The mean price paid is 2,000 and the standard deviation is 90. What is the approximate percentage of buyers who pay between 1,820 and 2,000? Okay, we already know about the mean and the standard deviation. Okay, so the mean is going to be in the middle, 2,000 here. Adding 1 standard deviation will be 2,090. Subtract 90 here, that will be 1,910. Okay, right? So now we want to find out the percentage in between 1,820 to 2,000. Okay, so we want to figure out what is the area of this part using the empirical rules. Okay, I just remind you guys this. 68%, that will be within the first standard deviation, like this here. Okay, 95% is talking about second standard deviation until here. Okay, so now we want to find half of it. So we're gonna say 95% divided by 2. Okay, one more time. 95% talking about from 1,820 to 2,180. But now we only want to find half of it. So that's why I divided by 2. You're gonna get 47.5%. So we could say about 47.5%. The data will be within from 1,820 to 2,000. Okay, B. What is the approximate percentage of buyers who pay between 1,910 to 2,180? Okay, so from here to here. Okay, so think about it. We could consider just like the part A here. If I cut off in here, that will be 95% divided by 2, right? So we find out this part. And then we still need to figure out from 1910 to 2000 here, which is gonna be within 1 standard deviation, but divided by 2. Okay, so 95% divided by 2, we calculate from 2000 to 2180. Second part, 68% divided by 2, we calculate from 1910 to 2000. You should get 81.5%. Example 8. The physical plants at the main campus of a large state university receive daily requests to replace fluorescent light bulbs. The distribution of the number of daily requests is bell-shaped and has a mean of 49 and standard deviation of 11. Using empirical rule, what is the approximate percentage of light bulbs replacement requests numbering between 16 and 49? Okay, this time I need to figure out what the numbers in here. And then after that, we could figure out the percentage by empirical rule. So first, we know about the mean will be 49, standard deviation will be equal to 11. And then mean 49, that will be in the middle here. Okay, and then we want to find out like from 16 to 49. So basically, we just need to figure out the numbers here. Okay, so first, we try to calculate the mean minus 1 standard deviation, which is gonna be 38. So we have a 38 here. Okay, then one more. We're gonna find the mean minus 2 standard deviation. So 49 minus 2 times 11, which is gonna be 27. Okay, last one. The mean minus 3 standard deviation. So 49 minus 3 times 11, which is gonna be 16. That's good. So now, we want to find out the approximate percentage in between 16 to 49. Okay, which is gonna be the 3 standard deviation. That will be about 99.7% divided by 2. Okay, because we only need half of it. And be careful, even though we calculate from 16 to 49, it doesn't mean this is gonna be 50%, because we still have a little bit percentage in here. Okay, so 3 standard deviation divided by 2. You're gonna get 49.85%. Okay, last one. The Chebyshev rule. Chebyshev rule states that the percentage of data in normal distribution within 2 and 3 and 4.5 standard deviation of the mean, approximately 75%, 89%, and 95%. Since the empirical rule only works for the bell shape, but Chebyshev's theorem, it can be applied for any shape of the distribution. Okay, one more time. Empirical rule only apply for the normal distribution, but the Chebyshev's theorem, it can be applied any shape of the distribution. So you could see this is not the normal distribution. But then we could tell about within 2 standard deviation, we do have at least 75% of the data here. And then within the 3 standard deviation, that will be at least 89% of the data. They still have the last one, 4.5 standard deviation will be about 95%, but I didn't show it in here. I want to let you guys know if you don't have the normal distribution, but you also want to find the approximate percentage, you may want to use the Chebyshev's rule. That's it.